Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and today we are programming and puzzle gaming. Yes. Today we're going to be looking at logic puzzles from AHA Puzzles, and these logic puzzles look like this, or at least this is the chart to help you solve these logic puzzles. But you have these clues, and then you have to figure out what the answer is. But we will get there later on. 539, welcome in. Salutation. But to help us solve these logic puzzles, now these are pretty easy. Like you can do them by hand, and we will solve one of these by hand just to see how to solve these. But we are going to use a programming language called Prolog. Such as so. Prolog, if you've never heard of it, is short for, or the name comes from programming logic or something like that in some language. But it reuses a paradigm called logic programming. And if you ever heard of declarative programming, it's the way Prolog is written is it's declarative programming almost to an extreme. And we'll see that in action in a bit. First, want to give credits. The thumbnail for the stream comes from a meme by Bucket3432. Great meme, by the way. Takes the Irwin meme where so I haven't watched Attack on Titan. I don't know who these characters are, but this guy says something or asks a question that's kind of weird. In this case, it's a Prolog query. He says, huh, and then says it's a strange thing to ask. But yeah, this was posted 2 years ago, 2021. And there is a bunch of useful and insightful comments by the Redditors here about how Prolog works, and a lot of deep dives into links with that have to do with Prolog and how it works, and brief explanations of what logic programming is. So definitely do check this out when you get a chance. Link is in the description. We have a repo for today. penbu.vt/prolog logic puzzles up on GitHub, also in the description. So if you want to follow along or reference these solutions after the stream, you're very welcome to do so. Okay, what else do I have in these links here? I will be using SWI Prolog because this is what's in the Arch repos, and I did not want to pull up GNU Prolog out of the AUR. Normally, I think if I were doing something in Prolog, I would be using GNU Prolog. Mostly because that was what I started with, and it seems to be... GNU Prolog is very close to ISO Prolog, which is the standard. SWI Prolog has a lot of extensions on top that is useful for real-world programming, as they say here. But I do like portability. Oh no, it's one of those languages with major dialects. Yeah, a little bit. So you do have the standard ISO Prolog that has, it's guaranteed to work across applications that adhere to the standard. But a lot of the implementations themselves add extensions on top. So SWI Prolog, for example, adds modules. So weirdly enough, ISO Prolog does not have a good, or have any standards for modules. So all the implementations, if they have one, GNU Prolog doesn't have a module system, for example. But SWI Prolog does. But yeah, the things like... I think you can open sockets even in SWI Prolog, and GNU Prolog I think does too. But each of these Prolog implementations are geared towards different things. So for example, the manual here says positioning of SWI Prolog. It goes through. I'm gonna make this a little bit bigger. I'm not going to read this. But it goes through what it's good for and what you should maybe think about using other Prolog varieties if you have other needs. For example, GNU Prolog is more suited for embedding because it's small, XSB for deductive databases. bunch of other ones here. But yeah, I will be writing this for SWI Prolog, but I think the way that we're going to be writing these, except for maybe the first line, should be applicable to most other implementations. But first, we're going to go with the logic puzzles. We're probably going to be looking at a bunch of different logic games, because we have Einstein's puzzle here, Greekist, logic equations, logic puzzles, and zebra puzzles. We're definitely going to be looking into one of these later on. But here we have basic logic puzzle 1. We have these clues here. Amy likes bananas, Belle isn't 10. The 9-year-old girl likes grapes, and Belle likes apples. And in these puzzles, you have one person is assigned one age and one fruit, and they never overlap. And so we have this table here, where we have the name of the person, and then their age, which is either 8, 9, or 10, and then fruits, which is apple, banana, or grape. And so based on these clues, we say Amy likes bananas, right? So we check Amy and banana, and then we eliminate the possibilities for the other ones because we know that Amy can't like apples and grapes because she likes bananas. And that means that Belle and Chloe can't like bananas either because there can only be one. The Belle isn't 10. The Belle is not 10, we know that. The 9-year-old girl likes grapes. So whoever's 9 years old likes grapes. And then Belle likes apples. And apples here. And so we know that Chloe must like grapes because we've eliminated all the other possibilities. And then what else do we know from this one? So if Belle is not 10 years old and the 9-year-old girl likes grapes, so we know whoever has grapes here is 9 years old. And so from the intersection, we know that it has to be Chloe. And then what else do we have here? We have Amy is either 8 years old or 10 years old. And then we have Belle must be 8 years old because we've eliminated the other two possibilities here. I don't actually remember how... Oh, right, because this was explicitly given. Because we know that Chloe... Chloe is 9 years old. So nobody else can be 9. And then we have Belle is eliminated here because we know she isn't 10 years old, so she must be 8 years old. And then we have Amy, the only one left, with being 10 years old. And now we just fill in the rest here. We know from here that Belle must like apples or bananas, but we already know that Belle likes apples, so... Is that how this works? Yeah, okay. I think that works. So then we have this completed table here. Amy is 10, likes bananas, Belle is 8, likes apples, and Chloe is 9, likes grapes. You can do that all manually, or we can get the system to try this out for us. So we're going to write a logic puzzle, or we're going to write a Prolog, program for this. Were you wondering how long it would take someone to ask what's up with the X logo SVG? I was not, and I actually kind of forgot that was there. I have that up because I have this other window here, so that we can move this over and reference the puzzle while we do the program. Yeah, good eye. Okay, right. I was going to give a quick introduction to Prolog before all this. So, Prolog, logic programming. What's a simple? Somebody give me a situation. I was going to do a family tree, but then the family tree ended up being a little bit more complicated than we needed it to be. Maybe we'll just go through one of these examples here. So, for example, here we have bear is big, elephant is big, and cat is small. So in Prolog, these are called atoms, and these are functors. By itself, a functor with an atom like this. So all statements in Prolog end with periods. These are called facts. And so we have all these facts saying Prolog, we're telling Prolog that bear is big, elephant is big, cat is small. And similarly, bear is brown, cat is black, and elephant is gray. You don't have to define all these, you just state them. Prolog also has rules, where you have a head and a body. And this means that X is dark if X is black. And similarly, X is dark if brown is X is brown. So I'm gonna copy and paste this into a program so we can run it. Example.pl. The general extension for Prolog is PL. Unfortunately, that clashes with Perl. But most of the time, I think you can figure it out from context. And so we run this by doing SWI PL-L and then example.pl. And this tells Prolog to consult the file. So this forms a database, essentially, or knowledge base, I don't remember what they call it, that has all these facts and rules. And so we can say, and now Prolog gives us a way to query the database. So for example, we can ask if a bear is big, right? You need to end things with periods. It responds with true because that is in the database. We can ask if bear is small, and it returns false because we haven't said that the bear is small. We can also go the other way. We can ask big X. Variables in Prolog start with capital letters, and that tells Prolog this is something you want to look for. So here we're asking Prolog what is big, and it goes through all the list of possibilities. So it knows that bear is big, and it knows that elephant is big because we've mentioned it here. But we can also ask it, is a bear dark? It is dark because we said bear is brown, and we've said that anything that is brown is dark. We didn't have to tell it that. We never explicitly said that a bear is dark, but it did manage to infer that for us. Similarly, we can also ask it, what is dark? We have a cat is dark because a cat is black, and this rule says that anything that is black is dark. And similarly, anything that is brown is dark, and we told it that the bear is brown. I think what really cemented this for me, though, is the concept of generation. So, we look at Prolog lists, no, append. The append function, we're not going to implement the append function, but there is one that comes with SPI Prolog, and it says that list 1, list 2, list 1 and 2. So it takes one list and it takes another list and it appends it, and the result is the third argument. So say we have a list here, and then D, E, F, and then we want to know what the result of that append is. You would expect here A, B, C, D, E, F as a single list, and that is what you get. You can also ask it if A, B, D, E, F is the result of the append here, and it should give you false. Or you can say what is the tail? So A, B, C, D, E, F, like this. What did we append to ABC to get this list? And it tells you D, E, F. Similarly, we can also make the first part a variable, and it'll go through all the possibilities. Prolog is great. But yeah, this is probably the reason why it's one of my favorite languages, if not the favorite, because you just tell it things, and you tell it what you want, and it just gives that to you. Prolog, I think, was created for AI applications, and I think it still has usages in AI. But otherwise, I don't think you see it very much, which is a shame because it is a great language. Okay, so back to this puzzle. We have basic 1 logic puzzle. We already know what the solution is, so we can check our Prolog program against it. So basic 1.pl. So we can say Amy is a person, and all atoms in Prolog start with Prolog. What is this complaining about? Oh, don't worry about that. Okay, whatever. All atoms in Prolog start with lowercase letters to distinguish it from variables, which start with uppercase letters. And so we also have person. Belle is a person. We say Chloe is a person. We have apple is a fruit. Banana is a fruit. And grape is a fruit. No, it's the other way. Fruit, grape. And similarly, we have... We might not need that one, actually. We also have 8, 9, and 10. Age 8, age 9, age 10. This feels a little bit unconventional. So disclaimer, I don't actually program in Prolog. So don't expect any great Prolog code here, but I know enough to at least be able to solve these puzzles, hopefully. I didn't get a chance to practice before stream, so if we struggle, we're struggling together. And so, what do we have? We can, all we need to do is tell it the rules. We have a relation here where a person, age, and fruit. I don't know what we call this thing. Profile. Call it profile. Name, age, fruit. So we have name, age, and fruit, and we have person. The name has to be a person. Age has to be an age, and fruit has to be a fruit. So in Prolog, you can concatenate your conditions using the comma operator, and this says all these 3 have to be true for this to be true. And so we can start with this one. We know that profile, so clue 1 says that, well, let's start with a solution. Solution A. And here's where things might break down, because I don't exactly remember how we did this how I did this last time. So we have likes. We can start with the predicate like. Name fruits. Person. Oh, this isn't quite right. No, profile. So we have profile, we don't care about the age, and then fruits, like that. So in Prolog, you can ignore certain things by using the underscore. And so now we have a relation called like. It is a predicate that makes a relation between names and fruits. And we're saying that if a person likes the fruits, then there must be a profile that has both the name and the fruits inside them. Likewise, let's create a predicate called isAge. Name and age. And similarly, we have a profile where name, age, and we don't care about the fruits. Actually, we probably don't need all these extra predicates. I'm gonna comment that out because I don't think we need these. So we have a predicate called solution. Solution 0a. Call that S. Doesn't really matter what we call it. We have a solution S where we have profile Amy underscore bananas. And we also have a profile where Bell is not 10. And we're going to have to figure out how to encode that later. We don't care about the fruits. We have a profile. Something where we don't care is 9 and likes grapes. Grapes. And we have another profile where Belle likes apples. Underscore apple. Okay, and then we end that there. I feel like we're missing something. So we have this variable s, and we actually have to use s, because otherwise Prolog will complain. So that is our error check. So s is some list where we have a profile VC, profile Amy, Belle, and Chloe. All right, well, let's fill in the names here. Amy, Belle, and profile Chloe. And so we know that this has to be B. This doesn't feel Prolog at all, actually. I feel like I'm putting in too many things here. I might have to go back in some of my old code and see what I did for other things. No, this doesn't seem right. This is why you practice before it's stream. We have a member, house red English. Okay, hold on. I'm going to look at some old code and see if I can gain any insights on how I did things before. If I can remember where I put these things. So many personal projects and repos, and sometimes organization goes on the wayside. Or you can just look up how to do it here. I do have a few other links open here. So one of the things that I was looking at this week was this library called CLPFD, which is the constraints logic programming for over finite domains, which adds constraints to the problem so that Prolog doesn't go searching for a whole bunch of things it doesn't need to. Probably can't read this. And so I don't remember using is at all. Okay. I think I found one of them. All right, I found one of them. So we have all these. We can encode all these hints as facts. Okay, got it. So I'm going to get rid of that. So hint 1. Where we have a solution is that profile we're going to use the member predicate. So member is a predicate that says this item is part of this list. So in this case we have solution as a list. So member profile, we have Amy likes bananas. So Amy, then we don't care about what the age is, and she likes bananas. Okay, so that's hint 1. Hint 2. We have a member. Profile Bell is not 10. Is this backslash? The backslash in Prolog means not, is negation. Hopefully I'm using that right. Bell 10, and we don't care. We'll find out if that actually works. Then hint 3, we have member profile. Whoever is 9 years old, she likes grapes. And hint 4, profile. We have Belle likes apples. We don't care about her age, but we do care that she likes apples. And so from there, we have a solution S, where S, where hint 1 is true, hint 2 is true, hint 3 is true, and hint 4 is true. I think we're probably missing something. Okay, well, let's see how this works first and see if we get a sensible answer, and if not, we'll have to add something. Uniqueness, yes. You're probably right. So there's this predicate called all distinct. I may or may not need, actually. Because this is part of the CLPFD D library, and we're not using that right now. Well, we can say all unique. Well, I mean, that's what this is. So map list in versus V's. True if bars are pairwise distinct. For example, okay, so this takes a list. But if we want to spell this out, I don't really want to spell that out. We might want to consider using that. Where do I put my distinct check in here? Okay. Yeah, so I think we might actually have to use that then. Use module. Library. CLPFD. So this tells us to import the CLPFD library. In many Prolog implementations, this is already provided for you because it's a very common library to use. So in this case, but not in the case of SVI Prolog, because their CLPFD library was added much later, I think 2006. So how do we say this? So in a set of profiles, we have this predicate called map list. Map list 3, I think it is. And in Prolog you have when you specify predicates, it's always the name and then the arity of that predicate. So here in map list we have a goal, which is basically going to be almost like a function here, and then we have a list, and then that's the results, which we get somewhere. So in this case it is, I think it's in mapped to this. Wait, what? For example, all distinct can detect that not all variables can assume distinct values given the following domains. Okay, well, let's put it this way. We have a solution S, where we have, so let's start building this out. We have a list where we have a profile A, B, C, profile D, E, F, and profile G, H, I. We could probably give these better names, but that's okay. So I have these profiles, and then we can say that we do have to wrap this in something. Unique solution. And we can say to all distinct A, B, C, D, E, F, G, H, and I. I think that'll do it. And then we have to say unique solution here, where it should be able to figure out that S is this list. And then it goes through all of these. Now the order matters. Wiley, welcome in. The order of these clauses matters. So it might be the case that we need to put this at the end, but we will find out. So basic1.pl. We're gonna move this back up. And hopefully we can just say solution S. query the database for an S and it should spit out a solution for us. Of course not. Some frames are missing due to your last optimization. Call unknown procedure all distinct 9. Because this needs to be a list. Alright, solution S. I think once we figure out how to solve this one first, the other ones will be pretty similar. Clause term position 3 cannot represent due to int. Right, okay. And this is because all distinct works with integers only. Because I pulled it from the CLPFD library, and that only works with integers. How do I do a uniqueness check without CLPFD? Oh, yeah, right. No, that's all right. So we can do this one. Let's implement our own all distinct. We're gonna get rid of this one. We'll learn how to use the TLPFD library in a later one. So let's say unique A, B, C, or X, Y, Z. So unique X, Y, Z means that X is not equal to Y, Y is not equal to Z, and X is not equal to Z. Pretty straightforward. And so here we can say that a unique solution says that A, D, and G are all unique. And we can say that B, E, and H are all unique. And we can say that C, F, and I are all unique. Alright, let's try that. See what we get. False. Why is it false? Alright, let's move this down here. And hope that's just a case of the order mattering. Whoa. Unknown procedure. What do you not know? The not. How do you negate a clause in Prolog negation? I thought it was that. Oh, it's plus. Okay. It's backslash plus what we want. And now it's going to search through a whole lot of stuff. And this is why you use CLPFD, because then it doesn't search for everything. So we might actually have to start learning how to use CLPFD here. Yeah. Okay. Breaking down, I guess we have to learn how to use CLPFD. So in the docs here, and I have it loaded up, it provides these constraints. V equals, greater than, not equals, and then we have the membership constraints in and ins, and those are probably the only ones that we'll end up using. Honestly, I should have learned this before stream, and this makes things a whole lot easier, and then we wouldn't have to go through all this. But the way that CLPFD works is that it all runs on numbers. We go to here. I had one link here somewhere open that had logic puzzle with CLPFD. So we're probably going to do something like this, where we have a set of people, a list of people, and a list of ages, and then a list of fruits, and then we give them names here, and then we pair them all together, and then we make sure that they're all distinct, Where's table? That is table. And then we do all of this. We're gonna have to figure out what it is that we have to do here. I'm gonna move this over here to the right side. And we are just going to try to copy this. So in our case, I'm gonna save this somewhere. Just so I have a copy of it. But otherwise we're gonna get rid of most of it. I move this down. I'm gonna get rid of this because we don't need that. Are you able to see both of these? Yes. Okay. So we have a solution. Pairs. Who drinks water? Who owns a zebra? So actually, we don't want that. We want a solution S. We'll find out if we can use S. So we have names equals some list with Amy, Belle, and Chloe. And ages equals 8, 9, and 10. And we have fruits. Go back up here, fruits. Apple, banana, and grape. And then we can give them names. Sure. Amy, Belle, and Chloe. Actually, I'm going to call these name Adams. Name Adams is equal to those. And then we were probably okay from there. I don't know if we need any more. And if we do, we can just add more of those. So then we have pairs, keys, values. Which I don't think we actually have pairs. Because pairs is up here. Sure, let's go with S. So these pairs here, and we have names, name Adams. Basically, pairs, keys, values will take a list of names and then a list of atoms, and then more or less invert is not the right word. Pair them up. So the first elements pair up with each other. The second elements pair with each other. Keys and values, basically. And the resulting list is here. Or because it's Prolog, you can have a list of those of pairs and then split them up into key and value lists. So here we're pairing the names and the name Adams so that we can label Amy with Amy, Belle with Belle, and Chloe. Because remember, these are all going to be numbers, and so we need to figure out what those numbers are. We can say map lists all distinct. All distinct and table. All say table equals names, ages, and fruits. So every element in those sets have to be distinct. And so this is a table. And then we append the table to V's, where V's, each element in V's is within Well, this is 1 to 5. Where did it get 1 to 5 from? Let me move this up here. And then make this bigger, because I realize you probably can't read it. So 1 to 5, remember that these are all integers. So if the position of a house is represented with a variable h with domain 1, 2, 3, 4, 5, then the following relation holds for any neighboring house stats. We don't care about that in our specific puzzle. Man, I wish I had time to prep for stream. We might not need this. It's possible that we don't need this. But let's start with our clues. We can at least encode our clues. And actually, I'm not sure this works either, because we need a relation. I think we still need a relation profile. Do we need a relation profile? We need some way to relate names to ages to names to ages to fruits. We still need some way to do that. And this also has that kind of thing. I just got to figure out where that is. Because in this case, houses, nations, names, drinks, smokes, and animals, those are all grouped together in some way. And is this because of the pairs keys values, or is this because of the table here? It might be because of the table. Okay, I see. The 1, 2, 3, 4, 5, the V's here, the 5, it comes from the five people. Okay. In this case, our the pen table V's, where our V's is ins 1, 2, 3. And we will find out if this actually works. And then we can say Amy likes bananas. Using the CLPFD predicates hash equals for constraints. And we say that Bell is not 10. 10. And the 9 is equal to grapes, because 9 likes grapes. And Bell likes apples. So those are our hints. So we can label this hints. Hint 1, hint 2, hint 3, and hint 4. And then we have these next two, which for us, we don't care about. Yeah, so these are all the hints that we have. And so now, hopefully we get a solution. We still haven't used S though. Oh, actually, no, we have used S. The pairs keys value is S, so the pairs is what we're going to get here. And this might be enough. And then we label the S like that. I have no idea if this is going to work. Syntax error operator expected. Map list, hello? I think this needs an, does this need an output? Map list, where are you? Oh, it allows you to have just one. If goal is successfully applied on all matching elements of the list. Ah, it's because I'm missing a comma there. And I'm also missing... comma here? No? This one might be okay. And it's probably not going to be okay. We're going to try anyway. Solution S. Unknown procedure solution 1. DWIM could not correct goal. So this might actually matter. Okay, so what's wrong here? Oh, append, because append has... append takes 3 arguments. So append we have arity 3, but does it also have arity 2? It does. Okay, so it's a list of lists. Concatenate a list of lists. If true, then the concatenation is a list of that. I see. So we have a bunch of lists here, and then it's it concatenates them into a single list. So what's the syntax error? This doesn't help me, Prolog. Operator expected. Which operator? So I am using CLP. Oh, right. Use library. This is pretty important because I need to use the CLPFD library. Use module library CLPFD. Now this should be enough to take care of that. It's still complaining, but maybe it'll be okay because ins comes from the library. So solution S. Some frames are missing. We still get integer expected found Amy, a compound. Well, at least the syntax error went away. So what are you complaining about? Nations and names. Oh. No, that can't be right. No, this should be fine. So, like, so we have the names, but they're all names here. But this sets up the pairing so that we can associate them with something. But it says type integer expected found the atom compound. Why? What if we don't have this? But we need it. We need it for the pairs keys values. Well, we can try to get rid of this and see what happens, because we don't use the name atoms anywhere else. But then what's going to happen is we're going to end up with a list of integers, and we aren't going to know what those integers are. Arguments are not sufficiently instantiated. Okay. That tells me we're missing something. That tells me we're missing something. I don't know what we're missing though. Okay, what if we get rid of this one and just get one of these, and then we get rid of these two as well and see what we get out of that. You're supposed to give me what S is. Ah, alright. Well, I suppose we haven't really gotten to the mind-blowing part yet. It's, what is wrong here? Okay, so we put that back, and then what do we get? Solution S. Okay, well, I guess that's something. This actually kind of makes sense, because we did say there was only 1 and 3. But then we need to label it with the V's. Ah, okay. So actually we need to label it with the V's here. I misread the solution. So actually we don't need to put that there, we can just put that here. So now we're saying that for name, age, and fruits, we label it with one of these names. And actually we kind of do need this. Let's try that again. Well, we're getting somewhere. A, B, C, D, F, and B, A, E, which I think is wrong. Because yes, these are all distinct if you do them all pairwise like this, like 3, but they all need to be distinct from each other too. So something in our code here is wrong. What if I follow... Oh, wait a minute, hold up. Punctuation is important. That's why we weren't getting anything. So Amy, Belle, and Chloe... I don't think this is quite right either. But we're getting closer. So I think these gets us... What if we made this 1 to 9? Because we have 9 things. But I don't think that works, because then what happens is we have no relation between these things here. Yeah, that's not quite the right way to do it. Maybe we try to do this without CLPFD. Go back to our previous solution and just try to fix that. Which I'm going to pull up. I'm going to pull up here. So we have Amy as a person, Belle as a person, Chloe as a person. We have apple, banana, and grape as fruits. 8, 9, and 10 as ages. Our profile, age, fruits. Oh, okay. No, we have unique. We actually don't need... Boy, what was wrong with this one? What was wrong with this one? Did it just take a long time? Yeah, it just took a long time. That's why. So I'm going to change this actually. So it's going to be... I'm going to change this out so that this is not in there. It's going to be in here. So we have a unique solution A, B, C, where A is equal to profile name A, age A, and what is this, fruit A. And copy that 2 times. That's not quite what I want. I want age B and age C. And then I want to say A is not equal to B, A is not equal to C, and C, or A is not equal to, or B is not equal to C. So this is our uniqueness check. Or it's partially our uniqueness check. Because we also want to say, isn't profile a predicate, not compound? Yes and no. So they're... Actually, no, you're right, because this is a predicate, not a... So the compounds you're talking about are structs. But I wonder if they're interchangeable. We'll find out. Singleton variables, name C, fruit C. Oh, right, okay. So I do actually have to use something, do something with them. So we have unique. Name A, name B, and name C. And then instead of name, we have fruits. Right, no, actually we copied age, so this should be age. I still don't expect this to work. Solution. Yes. Solution with lowercase s. And it's still going to go forever. We can help it along a little bit, actually. Where we have S is a profile with Amy, B, and C. We can reduce its search space a little bit. Yeah, we can reduce its search space a little bit. But how do we say that S is in this shape? We can do it this way, where it doesn't have to be. Where we don't actually care what the other ones are. We just say that... Oh, so this is Chloe. And then we say that it has to be this way. So S is in this shape where we have Amy, Belle, and Chloe. Then we have our hints, and then we have our unique solutions. Alright, now hopefully this allows us to get something. No. Why not? I need to construct something. I'm gonna try that. The is. Type character expected, found profile Amy, something a compound. Character expected. Okay. So then I guess we have S is A, B, and C. Where A is equal to profile Amy, whatever. Vim. No, I'm just failing at Vim. And then C is equal to profile this, this, and that. No, I think what I do want this to be is. Okay. So, can we figure that out now? Solution S. Arguments are not sufficiently instantiated. We move that down there. Probably not. You might be right, and I think this profile being a predicate, it's probably not helping that. How did I do this before? Oh no, okay, no. So in what I had done before, it should be fine. I should just follow my previous example before. Okay, so hint 0. Hint 0 says that yeah, we're getting rid of this. Getting rid of this. And we're moving this up here. So hint 0 says that what we're looking for is a solution with these things here. Amy, Belle, and Chloe. And then we don't care about these ones, we just know that it's going to be in this shape. And so our solution is hint 0 with S. And hints 1, 2, 3, and 4. And then a potential uniqueness solution that we may or may not need. But let's find out. Solution S. We're still getting the wrong things. Hints 0, 1. However, there are definitions for hints 1, 2, 3, 4. I missed something. Syntax error, that's why. Come on. What if we get rid of this? What if we get rid of the uniqueness? Solution S. Still false. What am I missing? So my the example I'm going off of is a zebra problem. I'm trying to apply this to this other logic problem, which I'm not sure if that's working. Well, clearly it's not working, but we can try it for a zebra problem if we want to try to go for something that I actually have an example for. But it would be nice to figure out what's wrong with this, because this should just work. So we have a solution S. We have hint 0, which states that we have a thing of this shape. And then we have a profile S. So S here is a list, which we have here. And then we have that as knots. Okay. I wonder if the knot is giving us problems. Apparently the knot is giving us problems. Okay, so how do you do knots? Prolog. Negation. No, I looked this up earlier. Is a predicate to negate. Note that negate means you're not provable at that point. Oh! Right, no, okay, so this is actually wrong. It's not that we don't want member. We don't want that. We want member to be something where this needs to be more compact. So we have Belle as A. Let's say age here. But age is not equal to 10. I think that's what we have to say. So Belle has some age, but that age is not 10. Okay. Please. But at least it's at least it terminates. All right, what else is wrong here? Because if we do get rid of this, it gives us something. Right? It doesn't know what the ages are. Well, it knows what the age is for one of them, but it can't figure out the age here. Well, then with hint 2... Oh, no, we don't want to get rid of all of those. So hint 2, Belle is not 10 years old. We're saying Belle has an age, but that age is not 10. And then you unify all of these, and it should just work. What are we missing? I have this in the right spot. It says name, age, and fruit. Name, age, and fruit. So we know, at least from the answer that we got earlier, Belle is 8 years old. So we're looking for 8 somewhere. I'm gonna turn on debug mode and see what happens. Solution. S. Chat seems mighty delayed. I'm not sure if I can fix that, because I think I did make sure that I am on low latency. Okay, when I say ping, you say pong. Ping. 2, 3, 4, 5, 6, 7. Oh, a message got dropped, I see. Yeah, I sometimes in top chat, I wish I could set it to live chat for the chats on the stream. But yeah, if YouTube decides that your chat is low quality, it'll filter it out from top chat. I have live chats set up on my side, but not on stream because I can't figure out how to do that. Okay. Debug. I'm gonna reconsult that again. Go to debug mode. My quality mediocre and you will enjoy it. I certainly enjoy it. But I guess YouTube doesn't. What is wrong with this code? We aren't even using this unique solution. It's just a matter of these hints here. Okay, is not equals actually that. Prolog not equal. Diff. Okay, what is diff? The diff2 predicate is a constraint that is true if and only if A or B are different terms. If A and B can never unify, diff2 succeeds deterministically. Okay, I guess we'll use diff. It filled something in, but it doesn't know what it is. The diff A is 10, but we know that. Okay, so what's the difference between this and the double equals? That's another 3D here. Equivalent to not term is equal to... Okay. So then what is a double equals? True if term is equivalent to term 2, variable is only identical to a sharing variable. What is a single equals? Unify term 1 with term 2, true if the unification succeeds. Okay. So we'll try the not double equals and see if that helps. Still don't strictly understand what the difference is. Okay, so it terminates, but it can't figure out what the holes are. And we were able to solve this, so it must be solvable through logic alone. Hello? Okay, we're gonna redo this puzzle and see if see what we get. So hint 1 is Amy likes bananas. Yes. Which means the other two don't. Hint 2. Maybe we actually do need the unique solution. Hold on, let's try that. Unique solution. S. Further expected, because we still need that. I don't think this matters though, because it can already figure out that we have these solutions here. Yeah, that's what I thought. For some reason it just fails on actually we all turn all these into double equals. Unknown procedure solution 1. Because I forgot the comma again. Okay. We're gonna try to solve this again. So we know that Amy must have bananas. Belle is not 10. And we're gonna skip that one. The 9-year-old girl likes grapes. The 9-year-old girl likes grapes here. And then Belle likes apples. And so what did it figure out before? It managed to figure out... I'm gonna just run this again. So I managed to figure out that Chloe is 9 and likes grapes. And it knows that because Chloe and grape is the only solution here. It figured out who has bananas, who has apples. Because it was explicitly said that Belle likes apples and Amy likes bananas. So that means that Chloe has to have grapes. Even though we never explicitly said that they must be unique. Really? Oh, but then we said that whoever's 9 likes grapes. So if you say... And then you had to figure out that the 9 years old likes grapes, and we explicitly said that... How did it figure this out? Hold up, we didn't give any uniqueness clauses. What if instead, so constraining uniqueness, we constrain that each atom shows up somewhere, the way we do for names? The hints already cover that. They kind of do, yeah. Because we never said that these only have to show up either... one, we never said that these can never show up more than once. But we also didn't say that these have to show up once. Okay, so going through these rules again, we have profile, name, age, fruit, where the name has to be a person, age has to be an age, and fruit has to be a fruit. Hint 0 says that our solution is of the form rows, where we have Amy, Bill, and Chloe. Hint 1 says that in our list, in our solution, actually, I'm just going to make sure that this is the right way to call this. Predicate equals member 2. True if element is a member of list. Okay. NSFW Prolog definition differs from the classical one. Our definition avoids unpacking each list element twice and provides determinism on the last element. For example, this is deterministic. I don't think it really matters for our case. Maybe it matters that this is there. Or maybe this... Okay, so my suspicion here is that this is not sufficient to say that whatever the age is not 10. Which, I mean, in my view, that's exactly what it says, but maybe that's not sufficient for Prolog. Maybe this isn't the way to do it. So we're saying age is not 10, and then we know that Bell has to be of some age. But we're trying to unify it, so we're trying to say that it must unify with something, but it doesn't unify with 10. This predicate is logically sound if its arguments are sufficiently instantiated. In other cases, such as this, the predicate fails, although there are solutions. This is due to incomplete nature of plus. To make your programs work correctly in also situations where they're not sufficiently instantiated, do that. Whereas, we have the double equal sign, equivalent to term, right, let's get rid of that. True if term 1 is equivalent to term 2, variable is only identical sharing variable. Equivalent, what does equivalency mean? Oh, Prolog, variable not equal. How not equal works? Oh, okay. What is this? Prolog, why? Consider using diff. Safe approximation of diff is possible in ISO Prolog 2. Yeah, okay, no, that's what I thought. You say that these two are not equal, right? You can use it earlier in the predicate. So let's try this diff thing again. Still didn't quite work. That's what we got before. But we also had this. This operator is mostly used for numerical values and arithmetic operations. Term not equals. You don't say anything. Value 9. Prolog. Okay. Sorry, let's make this a little bit bigger. So with numbers, I think you use this. Okay, let's go in the REPL here. 10 equals 9. Arithmetic, okay. But if we say that 10 is not equal to 9 like this, That is true. This is also true. So if we say that S is profile, bell, 8, and some sort of fruit. What was the fruit? In our answer we had bell as apple. And then we say that member, profile, bell, age, we don't care. We need to find out with S. Legal start of term is. Do I have my parentheses in the wrong spots? Profile bell age. I guess I can't use this. Okay. Apple. Oh, actually, sorry, no, I'm missing a term. Because I need age to not equal to 10. Character expected found profile. But this clearly works. Okay. We're not ending yet, but I have a feeling that we're probably going to redo this once I actually figure out how to do this. Because most of the stream has been debugging. But we're going to keep going. And hopefully by the end of this we figure out how to do this. Okay, so we're gonna put a bunch of stuff in here. So the Prolog REPL is kind of weird in that you have two modes of operation. You have the consultation file where you put all your rules and your facts, but then you also have in your REPL you're in query mode where you have the database, all your consultation file, all loaded up, and then you query it based on that. And you can't add more rules to the database, which is kind of annoying. Or if there is a way, I haven't been able to find how to do that. So we have a predicate called test. We have that as S. We assign S. This reminds me of when I tried to solve 8 queens in the Rust type system as a live presentation for a research group. Yeah, I guess type systems would be able to do logic stuff like this, wouldn't it? Yeah. Did you end up solving it? And within a reasonable time? Profile, bell, and... Actually, no. So we don't do this. We don't do this. We have member... Actually, hold up. We already have that. We can just call hint2 directly. Bell 10 and what is this? Great. Alright, apple. False. Because it's not. True. That is correct. That is also true. So imagine if the case is that we just have a bad puzzle. But clearly we were able to solve this through, or were we actually able to solve this through logic alone? Okay, so we know that Chloe is 9 years old because we have this intersection here. We might actually just have a bad puzzle. How did we figure this out? And then we know that whoever has a banana... So Bell isn't 10. So this is the clue to actually get everything else. We know that Belle must be 8 years old. But then how do we tell it that? So I think that means that we do need the uniqueness check. Oh, no. That's not what that is. Hint 0 says that we have a thing of this form here. That also says that this is age A. I'm gonna do this for this here too. This is B. This is C. Age, or not. Fruit A, because we do need to tell it that these are all unique, because that's how we figured this out. We said that it isn't 10, or Belle isn't 10, but it doesn't know that it can't also be 9. So from here we have member. What is this? Map list is probably the way to go here. Map list 3. True if goal is successfully applied on all matching elements. The list, map list, family of predicates. Is that? But I don't know how to actually use that, so maybe not. So we say member, the apple is in fruit A, fruit B, and fruit C. And we do that for the other ones too. There's got to be a more efficient way of doing this. I did get a solution afterwards. Reasonable time is a matter of perspective because computation happens at compile time. Yeah, I guess it might take a long time if it's that. Is Rust's type system Turing complete? I think TypeScript is, from what I remember. Prolog is Turing complete, by the way. You can get infinite loops here. 8, 9, and 10. We change all these fruits to age. Syntax error, unexpected end of clause, because we are missing something. Okay. Just barely. Posted, you're not expected to understand it. Yeah, posted in the Discord. I will not expect to understand it. Solution S. Finally. Okay, so there was just something wrong with our code. Got the first one done. So yes, we do need a uniqueness check because we need to tell it that it can't be these same ones. Now, how do we get this in a way that is not so verbose? Okay, I think the way to get it to not be verbose is to do something like this, where we end up having to do that kind of stuff. But okay, we solved one. That means we can use this kind of template for all the other ones. I'm going to remove this and replace it with what we have here, because that's what we actually did. There is probably a solution with CLPFD. I don't know how to do that. the next time we do this, and I think there will be a next time, I will make sure to have learn CLPFD and then actually use it. Okay, so that's basic one. I'm gonna put a link here just to make sure we know that it's from there. And we can get rid of this because we never used it. We also get rid of unique because we never used this. I wonder how this worked. Ah, okay. And we never use unique solutions, so we can get rid of that too. Okay. Moving on to basic 2. This first puzzle took us 1 hour and 45 minutes. Minus 10 because I spent 10 at the starting screen. I was hoping to get to some of these featured ones, but it looks like we're going to have to stick to basics for now. Basic 2. Okay. I'm going to put a link to here. Set ft equals Prolog because it otherwise sees this as Perl. So, what do we have? We have same thing. We have sports, basketball. All right, you got a drop. Thanks for coming. Thanks for struggling here with me. Yeah, like I said, next time we do this, hopefully it'll be a lot smoother. Sport football and sports tennis. All right. Well, if you see this in the VODs, welcome to the VODs. Hopefully the next parts are a little bit smoother. No guarantees. Try to do something maybe a little bit harder too. Age 12, age 13, age 14. This surely should not be the way that we have to do this. And then person name Carter, name Luke, name Theo. And then we have hints. Hint 0, where we know that the solution must have the form. We'll take our profile from before. Name, age, and sport. Name, sport, age in this case. Replace all of this fruit with sports. And then from there we can do this. We have profile. We have Carter. Something. Sport A. Age A. Profile, Luke, for A, age B, and profile Theo, port C, this actually should be a B, port C and an age B, age C, getting my letters all mixed up. And then we check that they're all unique. So this is the point where we maybe figure out how we do this more efficiently. Oh. And then we can say that Okay, so we have hint 0. Yeah, we don't need this. We don't need this. No, that doesn't make any sense though. So profile already takes, because this here, what we're basically saying here is, oh no, I guess it kind of does. Because we're saying that these 3 have to be there. Sorry, I was thinking that we could maybe replace this with a check that, let's say, age is this, but we can't actually do that. We can't actually do that because we have no uniqueness check. But I think what we can do is use map list. We use map list to do something. I just got to figure out how to use map list. List 1, list 2. True if goal is successfully applied on all matching list elements of the list. The map list family of predicates is defined as this. Example is apply predicate to each element of the list. Or plus. And then generate solutions, which we don't want. Fill a list. Equals foo L. Test for atoms. Oh, this might be what we want. Or not. We can test that everything is, we can assert that everything is, we can assert that everything is an age, but we already know that because this is a profile. We have asserted that this is an age. Test for integers in a range. Nope. Convert CSV columns. This is probably more complex than we need it to be. And counting word frequency. Word frequency counts. Map list down case atom words, L words. So we can look for Prolog list contains multiple items. I need multiple items. Multiple items. Now is it subsets? So a member element of list, so we're already using this one. Select is true when list 1 with element removed results in list 2. Implementation is deterministic if the last element of list 1 has been selected. I don't think that's what we need. Select from 2 lists at the same position is also not what we need. Semi-deterministic version of select 4, nope. Delete nth 0, nth 1, last proper length, same length, reverse. Permutation. I think I do need an all unique one though. Prolog all unique. Or all distinct. Oh, distinct. Here we go. Something that's not all distinct because this is for CLPFD and we don't have that loaded. So it could be that we need distinct and this is already loaded, I think. So true if goal is true and no previous solution of goal bound witness to the same value. Equivalence testing. Answers a ground turns, the predicate behaves as the code below. Member goal and set. Find all. Find all 3. Create a list of the instantiations template that successfully on backtracking or successively backtracking goal to unify the result of a bag. Why don't you have any examples? Find all 3 is equivalent to bag of 3 with free variables appearing goal scope 2 goal with an existential caret operator except the bag of 3 fails when goal has no solutions. It's a lot of words. Unify bag with the alternatives of templates. So if C, who A, B, C, and C's, bag of C. Unify bag with the alternatives of templates. If goal has free variables beside the one sharing template, bag of 3 will backtrack over the alternatives. I don't really understand this. So we have listing foo, ABC, whatever. So bag of C, foo, ABC, and the C's. C is C, D, E, F, G. Okay. Oh, we have listing. Whoa, hold on. What does listing do? I think this might be... This might be what we want. Listing 1. List matching clauses. What is either a plain specification or a list of specifications? Plain specifications are these. Following options defined. So we can say that... But maybe not. So I don't know how to use that. This is part of the query. How do you get C's from this? A bag of C. Oh, I see. I see. Okay. But then how do you get this? So C's is... Again, we had map list. No, that's not quite it either. M sorts and clumped. Clumped. Okay, what does clumped do? Clumped 2? Pair is a list of item count pairs that represents the run length encoding of items. That's not what we want. Surely there's got to be something in here for this. I think map list here is the key. I just got to figure out. Prolog contains subset of items. Right, actually we can just use subset. I think of that. Subset 2. Maybe subset 3. True if all elements of subset belong to set as well. Membership is based on... Okay, so we can do that. Subset. And we say 8, 9, 10 all have to appear in age A, age B, and age C. So this is shorter. And we're going to put that in here. So then the question is, how do we get all of the terms that are part of this? List all facts. Find all. Okay, no, it is find all. So we want find all. Find all 3. Possibly. So yeah, find all 3. So people L. Find all X where X is man and woman, and L. Okay. So find all items from this list and return the list of items there. So in this case we have subsets. Sports. Let's say find all sports from sports sports here, and we get sports. And then we get the subset of sports, and that has to equal the list of sports A, sports B, and sports C. Okay, now we're getting a little bit more efficient here. And then we, instead of sport, we have ages now. Sport age G. Is that it? I think that's it. That's it for hint 0. Alright, that took a while. Now we do hint 1, where we have Luke does not like tennis. So I have the solution here, where we have member, profile, Luke, sports, and we don't care what the other one is. We don't care what his age is, and we want this to be a member of the solution. And we say that sports is not equal to tennis. Okay, so that's hint 1. Hint 2 is remember, Luke is not the youngest or the oldest boy. We have to turn these into numbers. I think we might have to turn these into numbers. I think we have to turn these into actual numbers so we can have we can compare stuff. Illegal start of term, because this cannot be the thing. So we have member, profile. Where did profits license.txt come from? Luke, or the oldest kid, likes basketball. The oldest kid likes basketball. Basketball, where, and then age in S, where age, and this is where we do map list. Less than or equal to, greater than or equal to? Greater than or equal to. I'm gonna move this down just so we can see it better. Greater than or equal to. I think we have this as age here. As ages, where ages is find all age, ages, since we're doing this multiple times, I think it might be useful to make a predicate for it. Ages is equal to this stuff here. We're going to call that all ages. And then since we're doing that, we're going to do all sports. Is equal to find all and all this stuff here. We have the subset sports, sport A, B, C, alright, A, B. And then we can replace this now with all ages. And so now we have a map list of age to ages. And then we are asserting that whatever the age is, it has to be it It has to be the most, the greatest. Okay. Operands. Profile, and I don't think we care what this one is. Whoever likes basketball is of an age, and that age is the greatest of all the ages. Yes, okay. Let me say hints 3. Member profile, Luke is not the youngest or the oldest boy. So we don't care about the sport, and we do care about the age. And then we say map list. There's got to be something here. So we have map list. If it fails for greater than and it fails for less than, and it assumes that one of them is, there's got to be a way to say this, is not the youngest and not the oldest. So yeah, if we say that it isn't the youngest, then that would be equivalent to doing all ages, right? And then you say not youngest. And the youngest check would be this here. Well, this is the oldest check, we may as well keep that around. But also not the youngest. And we end that. So we take all ages, and we say that age, that's the youngest, and we're saying it's not that. And then this is the oldest, and we're saying it's not that. Hint 4. Theo is not the oldest boy. Remember, profile, Theo. We don't care about sports. We do care about the age. Where we say that not oldest, which is what we had here. Okay, so now we've encoded all of these hints. So hint 0 says that we must have a solution that has this shape, where we have 3 profiles, and these are all distinct. Hint 1 says that we have a profile with Luke, who plays a sport, and the sport is not tennis. Hint 2 says that we have a profile who plays basketball, and with an age, and that age is the oldest. Hint 3 says that Luke has an age, and that age is neither the youngest nor the oldest. And hint 4 says that Theo is not the oldest. Okay, so now we go to our solution, which we can just pull from here, because these are all the same. Singleton variable in plus ages. Singleton. You're unifying with this, though. Singleton. Do I have to put this in the back? No, I shouldn't have to. Okay, well, we'll find out. We'll find out what happens there. Saying it's in plus. Okay, well, let's run it and see what happens. Maybe it doesn't matter. Solution S. Warning, singleton variables S ages. Okay, so it's saying that S is not found in line 29. Ah, right, okay, so we don't have S here. We kind of do need. And then otherwise, it complains about what? What are you complaining about here? Line 30. It is also complaining about the same thing. Because we have not defined all ages to be this. So we need that. Okay, so now we should have everything. Then we get the solution. And we get an error. Because of course we do. Arguments are not sufficiently instantiated. Map lists. 13. Add user lib apply pl basic to 28. I think we probably need this first. Like I said, order matters in Prolog because it'll visit the early ones first. So we need to say what all the ages are before we can map through them. I was hoping we would get this, but it's still false. Okay. Why? So let's first say, and let's first make sure that all ages actually works. Yes. All sports actually works. Also yes. And then subsets, no, the subsets should work. So then the question then is, do the map list stuff works? Map list. 14. Ages, where ages is all ages, ages. Arguments are not sufficiently instantiated. Right, because I need this first. 12, 13, 14. Just bake it in. True. 13 should be false. 14. So 13, if I do this, and I'm assuming my logic here is probably wrong. 13, 12, 13, 14. I'm missing something. What am I missing? Is this not the right operator for it? Unknown option. Yeah, that's probably not the right one for it. So, Prolog, less than or equal to. Because of course it's that way. Prolog, why do you have to be like this? Okay. So that's why I didn't show up as an operator here. Dynamic contiguous we have all this. Sure. What are the @ sign for? I remember seeing the @ sign in places, but I don't remember what it's for. Prolog @ sign. Comparative operators that start with @ are more general than the ones that don't, with operators such as less than 2. You can only compare numeric values and expressions, so with less than 2 you can do this. You'll get an error if all the cases using the @ less than. You compare lots of different types and objects. Prolog. Probably don't care about that. Okay. This is fine. We've already turned these into numbers. So this should be fine. Solution S. Are we still getting false? Why are we still getting false? What are we missing? So just making sure. Subsets. All sports. Subset sports. What do we have here? Tennis, football, and basketball. I need it the other way. I need to make sure that this is a subset. No rule matches subset stats. Do I need to make it this way? False. Why is that? Subset 2. True if all elements of subset belong to set as well. Membership test is based on member checked 2. Complexity subsets. The set is defined to be an unordered list without duplicates. Elements are considered to duplicates if they can be unified. We have ordered subset, but let's check member check. True, an element is an element of list. This check variant of member 2 is semi-deterministic, typically used to test membership in a list. Okay, sure. What is wrong with intersection 3 in friends? Library list contains a number of old predicates for manipulating sets and resolved. Unordered list. Subset 2, subtract 3. I'll use member check 2 to find equivalent elements. Intersection. Subsets. Oh, okay, no, I got this, that means I got this backwards. Because this is the subset that we're checking against this one. So this, the one on the right has to be the one that is the real list. The one on the left is what we're checking against. So the one on the left is our unknowns. And the one on the right is our knowns. And we know what those are. So now we should get something. Solution S. And it's still false. What are we doing wrong? Does our hint 0 work? Our hint 0 works in some form. What if we use intersection instead? And we say I is the empty list. It's a little bit roundabout way of saying it, but so what we're saying here is that the set intersection between the sports and the ages. So if we intersect these, then we should actually get sports. Oh, this is wrong. This should be sports. And so the intersection of a set itself should be. All right. Intersection of its own thing should be. Note that duplicates in the input may result in duplicates in the outputs. Intersection. Library ORD set instead. Is this even in is this an ISO Prolog? No, I guess not. This is an NSFW Prolog thing. Ah. Okay. Member append prefix selects. So what was wrong with the subsets? Permutation platinum. So an intersection of two lists is the list of things that that the two sets share. So in this case, if this is the same as this, then the intersection should be itself. If it isn't, then it isn't. Hint 0. Oh, that's false. Okay. So something's wrong with this code then. It isn't the intersection that we need, it's something else. True of set 3 unifies when the intersection of set 1 and 2. The complexity of this predicate is set 1 times set 2. A set is defined to be an unordered list without duplicates. Elements are considered duplicates if they can be unified. Delete all elements in delete from sets. Deletion is based on unification. Member check 2. This is not what we want. Actually, kind of is what we want. Because we can say that they all have to be unique. So if we delete, then we should end up with the empty list. Subtract. If we subtract sports, sport A, B, C, and then we should end up with the empty list if they contain everything. Same thing with ages. This feels like the wrong way to go about this, but well, we'll see. Solution S. If hint 0 is wrong or is false, then that means solution is going to be false too. Why? Because I forgot to do that. Okay. Is hint 0? Oh, actually, hint 0 is still. So it is giving us. Okay, so it is giving us unique things now, which is good. That means something else is wrong. I don't know if subtract is the way to do that, but find me an unordered list without duplicates. Yeah, subtract at least seems to be okay. Perhaps it should be OR subtract. Diff is a set holding all elements in O sets that are not in O. Okay. What was the thing again? It said that let me get back into this one. Why don't they allow you to get to the specific page? Subset 3. Subset 2, that's what it was. Subset 2. What is wrong with intersection 3 and friends? New code should use OR sets instead. Okay. So this is new code. It says we should use OR subtract instead of just subtract. And so we will do that and see if there's any difference here. I'm not using OR subtract. I don't want to read up on that. But there's still something wrong with this code. Because if it's not going through all of these. So hints, let's go through this again. Set wrap so we can see everything. Hint 0 says that we must have 3 profiles, one with Carter, one with Luke, and one with Theo. Where we have sports and ages. And they all have to be unique. All the sports have to be unique. All the ages have to be unique. Hint 1 says that Luke has a sport, and that sport is not tennis. How do we do it for this one? We put this in front. I don't know if that's going to matter, but it's worth trying. And then we have the oldest kid likes basketball. We have a member. What if we put all this stuff up front? We figure out what the age is first. We figure out what the age is first, and then we say that the member is of that age, because there's only one of these ages that counts. So we do that again for this one. I am missing something. Singleton variable age. We take this, the member, move it down to the bottom, replace the comma with a period, put this comma in here, and then we rejoin everything else. Why are you complaining about it? I didn't do anything. Oh, right, because map list age here, because we don't have... We need to figure out what the age is first. But then why didn't it complain about it there? Prolog max. So it does have max. Evaluate the larger of expression 1 and expression 2. Both arguments are compared to after converting to the same type. Which is fine. How do we do max in list? Oh, so it does have max list. Okay, then we may as well use that instead of map list. Max list. The list that's ages and then the max age here. And then we have the member there. So then we also have min list, presumably. And then we also have max list here. And we say it's not max. And we also say same thing as the max, not the max. Here. I don't know why you're saying it's singleton, because we have to figure out what that is first. I think we have to figure out what that is. So this has to go in front. Because we have to figure out what the age is first, and then we say that it isn't the min and it isn't max. Okay, so I guess all the member stuff has to go first. No, but that did... Oh, it matters because we're negating. Right, okay. That's gonna take a while. Hint 0s, hint 3s. But hint 0 already gave us something, so that's maybe not quite right. Well, actually, Luke Football 13. Is that correct? Hint 3 just says that Luke is of an age that is not the most and not the least. So what if we do switch that around instead? We get Luke Football 13. Okay, so that can figure out the age correctly. So hint 3 is correct. And then hint 4 we can say false. So maybe this is why we're getting stuck. Because hint 4 says that Theo is not the oldest boy. So we're supposed to get from here either 12 or 13, but not 14. And if it unifies, then we should get something. So hint 4 is wrong, or our implementation of hint 4 is wrong somehow. I just gotta figure out what that is. So we're saying in the solution we have Theo has an age. Okay, age is the last one, and we're saying that out of all the ages, it is not the max. That looks correct to me. Theo is not the oldest boy. So what if we get rid of this condition here? So we should get partial solutions. All right, one by one. So hint 0 or hint 0s and hint 1s. Or even that doesn't give us anything. Hold up. You're supposed to give me stuff. So hint 0 is able to generate something. Great. Hint 0 for some reason is not able to generate everything. No, I can't be right. Okay. So is the problem our hint 0? Going back to the first one that we did, it is the problem with hint 0. Okay. So in the first one we did, it can generate all these possible solutions. But in our hint 0 here in basic 2, it only generated the one solution, which is not correct, because we needed to generate all solutions. And for some reason, we have Sport A, Sport B, and Sport C being auto-filled to the same order. And we don't need it to do that. Prolog, check to see if all elements in list. Because I thought it was subset. Because this is how you would implement it yourself. But SWI Prolog already gives us this. Instead of all items in the first list, the goal is to satisfy if there exists any one item in the list that belongs to the second list. SWI Prolog sets. List. So member, sure. We have that. And if we need to fall back on that, we will. Append, which we can't use. We also can't use that. Prefix is not quite the way we need. Select is not what we need. Is true when list 1 with element removed results in list 2. That is ordered. We can't have that. Select check. Select from 2 lists at the same position. True if X list is unifiable with Y list apart from a single element. I don't think this is what we need. I'm not entirely sure how this works. Oh, no, right, because it replaces that. Okay, that's not what we need. X2, nope, delete. Delete matching elements from a list. True when list 2 with, is a list with all the elements from list 1 except for those that unify with elements. I need this to be an unordered list. last. That is not what we need. We looked at this earlier. Permutation. True when x's is a permutation of y's. This is, I think this is actually what we need. Because it is a permutation that we have. Primarily intended to generate permutations. Okay, so this is actually what we need. Now the question is, do we need permutation or do we need is permutation? But this does generate all the permutations we want, so I think this... It's close. Carter basketball 12, Luke football 13, 14, 13, 12. This looks just about correct. Yeah, those are all permutations. We say is permutation, and how is this different? No. Semi-dead predicate is permutation too. So actually, I'm guessing because we don't have that loaded, we probably don't have it. So... Actually, no, it looks like we do have it. No, we don't have it because it's unknown procedure. Alright, hint 0, S. And then let's see which predicate here is causing us issues. Hint 1 apparently has issues. Unless they all have issues. Yeah, this looks correct. So hint 2, hint 3 gives us stuff. Hint 4 gives us stuff as well. So hint 1 is the one that has issues. Sport is not equal to tennis. Member profile Luke Sports and S. What if we move this over to the other side? Okay, apparently that matters. Which means we should be able to get a solution. S. There we go. Now we have a solution. And now we can check our answer, do this manually and see how it works. So Carter basketball 14. Carter basketball and 14. And we have Luke football and 13, and profile Theo tennis 12. Theo tennis and 12. And there we go. We have it all filled in. Check answer. Great. We have time for one more. I think we have time for one more. Now that we figured out how to do this, I think it should be a matter of just copy paste. Okay. Basic 3. And, well, right now we're going towards 3 hours. Hopefully it doesn't go to 4. Best case, this takes 15 minutes or even less. Okay. So we have... So we have a bike race with placements, color bikes, and then names. So placement 1, basic 3.pl. Pop this in here. placement 1, placements 2, placements 3, placement 4. I don't know why I'm typing this all out. Okay, so we have all our placements, and then we have name Austin, name Dominic, name Emmett, with 2 T's, name Xavier, and then bike black, bike blue, bike green, and bike red. And from there we have a profile. Oh. We have a profile, we have name, position, bike. I'm gonna change this to position. Sport, position. Global search and replace. And age is now bike. Okay, so now we go to our hints. Hint 0, similar thing. This is the format of our solution. We have 3 profiles, one with Austin, or 4 profiles actually. Dominic, Emmett, and Xavier, where these are position 1, position A, I don't know why I'm having so much trouble typing here. Position B. I'm going to change this to C and move this to D. And then instead of age, we have bike. Bike A, B, C, and D. Instead of sports, we have position. And then instead of ages, we have it's bike. Syntax error, illegal start a term. This one. Singleton variables position D, bike D. Because I need to add these. There's probably a better way to do this one too. Yeah, probably something like all positions on this, and then you have a map list over these, because this is all just a list. I'm not going to try to figure that out. Hint 1, with our solution. Emmett and Austin bikes are red and black, but not necessarily in that order. Okay. This is a little bit more difficult. We have member, profile Emmett, who has a bike A. Bike Emmett. We don't care about their position. And we also have a member. I'll put this on multiple lines because it's going to need a few more. A member profile, Austin, whose position we don't care about, and bike Austin. S. And we have permutation, like before, red and black. Bike Emmett and bike Austin. So we were saying that this Emmett and Austin have to have red and black bikes, but not necessarily in the same order. Okay, so that's hint 1. Hint 2. The owner of the green bike finished in first. This one's pretty easy. We have member profile green bike. We don't care who the name is. We have position 1 and green. Hint 3. Member profile. Xavier was the 4th. So we know that Xavier was the 4th place, and we don't care what bike he had. Hint 4. Member profile. Emmett didn't finish in 2nd place. This is Emmett. Let's put some sort of position. We don't care what bike he has. Can I put an underscore, please? And then we know that position is not equal to 2. Hint 5. 3rd place did not ride a black bike. So member profile. We don't care who, but we do want 3rd place to be black. Did not ride a black bike, so this is bike. And we say that the bike was not black. Okay, so now we have all our hints. We can just type up a solution. Hint 0, 1, 2, 3, 4, and then we need a 5th one. This needs to be a comma. Singleton variable is S because I forgot to put it in the member. Alright. Oh no, this is basic 3 now. First try? No, of course not. You never get these things the first try. All position 1. Right, because we never can, we never define those. So we have here all names, all positions. Sports, position G. And same thing with ages. This ends up being bike. I actually do kind of want to figure out how to do this one. But let's see if this works first, then we can refactor later. Of course it doesn't work. Of course it doesn't work. Does our hint 0 work? No. Okay, so that's a problem. because unbound variable. Actually, no, that's correct. Position, positions, positions. There's all positions. Produce something? Yes. Does all bikes produce something? Also, yes. Am I missing one? Position D, bike D. Well, these are all bikes and these are all positions. And I'm not missing one. A, B, C, D, A, B, C, D. All positions and permutation position. All bikes, permutation, bikes. So hint 0 should produce something. Did I save? I'm gonna save again. Hint 0, S. I'm gonna copy this. See if we get anything here. Why? Right, because position A, B, C, D don't exist. Profile. We got a name, position, and a bike. A name, position, and bike. A, B, C. Oh. Maybe this is how you get all the permutations. Okay, I'm gonna try that actually. Position, name. Maybe I shouldn't try this while I don't have a working solution yet. But we also do have a length predicate. Length 2. Firefox, don't do that. Okay, now Firefox hang on me. Alright, kill Firefox. Let me just make sure that I don't have anything else I need to kill. Okay, I'm gonna kill Firefox. Kill Firefox like that. And then I'm gonna hide my screen because I need to show or pull Firefox up again. Where is my screen? This one. So now I'm loading Firefox, and then we're going to restore the session, and hopefully we can just get back to where we were before. Alright, it's all loaded. Now I just get the screen back up. Like so. Okay. So our hint 0 isn't working. And I'm actually not going to do that because I don't want to deal with that. There's got to be a way to do that though. So all positions, all bikes, bike A, B, C, and D. Are we missing one? Oh, right. Okay, so I had 5 positions, but there are only 4 positions. That's why. You cannot unify something when the sets are not the same size. And you have find all, or all positions. Okay, so now we should be able to get generate a whole bunch of stuff. And then our solution, we should get a solution. Why? Okay, yeah, no, that's correct. So then we have profile Austin 2 black. So Austin is second and has a black bike. We have Dominic is first, has a green bike. Then we have Emmett in third place and has a red bike. And Xavier in fourth place with a blue bike, which is exactly what's left here. And that is correct. Alright, that took way longer than I expected for it to happen, but I think we finally learned how to use these kinds of puzzles. Next time, I do want to do this again at some point, because I did want to get to the zebra puzzles, and also maybe get to some of these, because some of these are probably going to be more interesting. But we got through the basics, we learned how to do all of this in pure Prolog. Maybe not in the ISO way, unfortunately, but at least it works. I will be committing these and pushing these up to GitHub so shortly after the stream, so if you want to check out these solutions, feel free to do so. And if you come across this video, for anyone watching and managed to make it this far and not mauled or ever get frustrated, if you know Prolog, please feel free to hop into the Discord server and post some resources, because it would be very good to learn how to do this stuff properly. Link is in the description for the Discord invite. Okay, as for next week, I don't know when I'll be available. I think I'm available on Wednesday, but I'm not sure about Tuesday or Thursday or Friday. I know one of those days I am probably unavailable. I just don't know which one. So it could be that we have one stream next week. It could be that we have 2 streams. I'm not sure yet. Schedule will be out as soon as I know. And when I don't know, or if I don't know, it might be that I'll just put a placeholder there somewhere. And you'll just know that one of those days is probably going to be a stream, and one of those days is probably not. Is there anything else left to say? I don't think so. Once again, this was using SWI Prolog. This probably won't work. I don't want to say it won't work in other Prolog languages or implementations, because it might. You just have to have the right predicates. Yeah. And then also a reminder to check out the meme by Bucket3432. It's a bunch of links to Prolog resources in the comments here. The link to this meme is in the description. Yeah, that's it. Alright, yeah, it's been 3 hours. I didn't expect to go this long. I didn't expect to only do 3 logic puzzles, but hey, we learned something. Hope you learned something too, and it wasn't too confusing. If this interests you, yeah, check out the Discord. And we do have a programming channel, and this is certainly on topic for that. Alright, I have nothing left to say, so I think that's it. Thanks for coming all, and see you next stream. Good night, chat.